Hi, welcome back to my channel and I hope you love the video. I've made a video on winds today explaining everything that was possible. If you have any doubts, any questions, please comment below so that I can answer them. And do not forget to share, subscribe and like my video.
Winds. We know that winds blow because of difference in pressure, and that is how the winds blow. Now the surface pressure of any location is plotted on a surface pressure chart. And how does a surface pressure chart looks like? It looks like somewhat like this. I'll show you an example with a picture as well, but this is just for your understanding. So if this is the area of low pressure, this is the area of, sorry, that is the area of high pressure, this is the area of low pressure. Okay, so this is how it looks like, and all these lines that I have drawn in circles, these are known as isobars. Okay, now we know that iso means equal, so these lines basically represent equal pressure. Okay, so now in the surface pressure charts, the pressure will be written along with that. So this entire line, I'll just put it a different color. So this entire line has this pressure. So it has the entire, this line represents 1000 hectopascal, right? Then we have maybe 1008 here and 1012 on this line. So this line represents 1008 and this is another isobar which represents 1012. So these are the lines of equal pressure. Similarly, in high pressure area also there are pressure values written. What can you see from these charts? You could see that high pressure area there is more distance between the isobars as compared to the low pressure area where the distance is less, right? So low pressure isobars are closely packed, whereas in the high pressure the isobars have a lot of distance. So this is where you could see that the closer the isobars they are packed, higher will be the wind speed, because the changing pressure is too much, it's changing rapidly. So I'll just write it down here. So high pressure area is basically where there is more distance between isobars. Okay, and what is isobars? Areas of equal pressure. Low pressure area, on the other hand, isobars here are closely packed. So closer the isobar, higher will be the wind speed. These are all important things that I'm writing, so remember this. So because the pressure is changing too rapidly in the low pressure area, the winds are also, the speed is also higher. Okay, and this difference that is there between the two isobars, the difference in the pressure, is known as pressure gradient. So what is, and this is a very important term, we'll be using it in the coming up topics in this video. So pressure gradient is basically the distance between two isobars. So it basically represents the difference in pressure. Okay. Now this is how a surface pressure chart looks like. So this is an area of high pressure, this is an area of low pressure. You will see that the distance here, if you see, the distance is less in a low pressure area, whereas from here to here the distance is much more, right? So winds are, the higher the wind speed is in the low pressure zone, and in the high pressure zone the winds are as compared lower, right? So we will talk about the direction of wind in the northern hemisphere. So whatever is happening in the northern hemisphere, it's the exact opposite in the southern hemisphere. So let us consider the northern hemisphere. Okay, so in the northern hemisphere the winds blow clockwise when we talk about high pressure zone. So here if you can see, so in this high pressure, this is high pressure. Okay, so winds blow. So if you remember what happens in the northern hemisphere, you can always remember what will happen in the southern. So just remember one, it will be opposite in the south. So blow clockwise. Okay, and this is your low pressure zone. So here the winds blow anti-clockwise. Okay, low pressure area is also known as a cyclone, and a high pressure, obviously it's an opposite, so this is known as an anti-cyclone. Okay, now what is important to remember here is that this was northern hemisphere. So in the southern hemisphere, it will be exact opposite. Okay, great. So this is what needs to know. Now what is important is how the winds blow, what is the direction in which they blow. So what is winds? Horizontal motion of air. Winds है क्या? सिर्फ कुछ नहीं है, horizontal, okay, motion of air. Okay, now how do they blow? From which direction to which? So they blow from high pressure area to low pressure area. That is how the winds blow. Okay, now wind direction is always given in the direction from which it is blowing. So the wind direction, when we say wind direction, what you need to remember is very important, and very sometimes people get confused is कि how do we see the wind direction, कहाँ से winds आ रही है, rather than seeing कहाँ जा रही है. So it is basically the direction is from where it is coming and not where it is blowing. And this can be represented in either degrees true or degrees magnetic. If somebody has given their navigation exam, they would know how this is. Okay, so it can be either in degrees true or in degrees magnetic. Now one more thing that you need to know is related to this. There is something called as ATIS and there is something called as METAR. Okay, so whenever METAR is when we read, it's a given weather report. There is a topic of METAR which I will cover in one of the videos. So you could just go on Google and search what a METAR looks like. So it is a coded way of giving you a weather, a standardized way. So it's a something that you read. So here the winds are given in degree true. Alright, and when we talk about ATIS, it is something that you listen. You must have heard a lot of pilots saying, okay, listen to the ATIS, right? So when you're listening to the weather, the wind directions are given in degrees magnetic. Okay, so this you need to remember. This could be also a part of your exam question. Okay, wind is always expressed as a combination of how in the METAR, we will be reading it later, but in a METAR, how is winds expressed? So winds are always expressed in a combination of their direction and speed. So where they're coming from, okay, so they are given in represented in direction slash speed. So how is it written? For example, if a wind is coming from 120 degrees and is of 15 knots, so it would be written like this. This is how it will be represented in a METAR. This is how it will be. So what does this really mean is, like for example, if I make a graph like this, okay, so this is 0 0 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. All right, now my winds are coming from which direction? 120. They're coming from that direction. So 120 is somewhat here, so my winds are coming from this direction. So this is how it will be represented. And what is the speed of these winds? 15 knots. So this is how it is. Now how do we know what is the direction of the wind and what is the speed? So there are instruments that cater for it. So these instruments you must have seen on the airports and maybe somewhere where they are used to measure the wind speed and wind direction. So this is one and this is one. This is known as cup anemometer. This gives you your wind speed. Okay, you can see the working online if you want. And wind vane gives you the wind direction. So now we need to know another two terms which are again important, could be a part of your questions as well. Two terms that we need to know. Okay, very simple, self-explanatory. So there is something called as backing and then there is something called as veering. Okay, so now what is important here to know is the definition, of course. So backing means direction of wind that is changing in the anti-clockwise direction. Okay, so the direction of wind that is changing in the anti-clockwise direction. And when we say veering, basically it is changing in the, I'm not writing the full thing so you'll know, in the clockwise direction. The change is in the clockwise direction. Now how do you see this? So basically you could say that if my wind was coming from you could say maybe like a 360 or 00 360 degrees, my winds are coming. Now anti-clockwise would mean in this direction. Now maybe my winds are coming from 320 degrees. So this is backing of winds. Okay, this is here the wind is backing. When I say it is veering, it is going in the clockwise direction. Now again my wind was first coming from 360, but now it's coming from maybe 50 degrees. So now my wind is veering. Okay, so it is in the clockwise direction. So these are the two terms that you need to know. Apart from these two terms, there are three more terms that you need to know, only the definition part, because again, once you know the definition, you'll understand what it means. They come directly in exam as definition. So there is something called as gust, there is something called as squall, and then there is something called as lull. So the difference is in the definition. So what is a gust? Which is sudden, okay, sudden increase in wind speed, and which only last for few seconds. आपने सुना होगा a lot of pilots say, the on the approach, or that the weather was gusty, or there were a lot of gusts on the approach. So this is what it is. So main thing to remember is sudden increase and few seconds. Okay, the time and what is the change. Now in squall again it's a sudden increase, but here what is the difference? This is in wind speed again. Okay, but now here the time is different, so lasts for a few minutes, so it's a longer change. Okay, so here what you need to remember is that there is a sudden increase and the time is few minutes. That's the only difference between the two. Now what is the lull? It's an opposite. It is a sudden decrease in wind speed. So these three definitions are very important to know. Okay, so now the next thing is we are going to understand the geostrophic winds. But before we understand, let's see what forces that affects that wind. So this is known as Coriolis force. There is a Coriolis force. So we know that our earth is rotating, right? So our Coriolis force is due to the rotation of the earth. Okay, so it's due to earth's rotation. That's the reason. So what it really does is, due to the rotation of the earth, what it does is, in the northern hemisphere, the Coriolis force turns everything to the right. So Coriolis force turns everything to the right, and we know that it's exactly opposite in the south. So in south it turns everything to the left. Okay, so you'll remember this diagram here. So whatever it is, is it me, is it the wind or anything, it will turn everything in the right direction, and in the southern it will turn everything in the left direction. This you will have to remember. So this is due to the rotation of the earth. There is a force that exists, that is Coriolis force. Okay, now let's talk about the pressure gradient force that we just did before. Okay, so the second force that is important to understand for understanding geostrophic winds is the pressure gradient force. We just understood that it is determined by the closeness of isobars. So closer the isobars, basically the difference in pressure is now less and less, the higher will be the pressure gradient force. Okay, you understood this? Great. Now these two winds help us determine the geostrophic winds. Okay, so okay, I'll draw a table for better understanding. So let's make a table and put a Coriolis force here and pressure gradient force here. Okay, so these are the two forces that we talked about. Okay, so Coriolis force, we know that it is due to the rotation of the earth. Everything in the right direction it turns in the northern hemisphere, and everything to the left in the southern hemisphere. And for the pressure gradient force, we already know the definition, that closer the isobar, the higher the pressure gradient force is. Okay, so this force, pressure gradient force, basically acts from area of high pressure to the area of low pressure. So the movement of this force is from high to low. All right, and here in the northern hemisphere, Coriolis force turns everything to the right, and in the southern hemisphere everything to the left. So these are the movement of these forces that leads to. Okay, now higher the pressure gradient force, higher the wind speed, that we've already discussed before. Now for Coriolis force there is a formula. that I'm going to write. You don't have to remember the formula, just remember that there is a formula and 2-3 things that we need to focus on. So this is the formula, that is 2 rho v sine theta. Ohm is basically angle. Okay, I'll just write it down that also. So this is basically ohm. This is your angular velocity of earth. Okay, so this is rho, which is your density. Okay, this is v, you know this is your wind speed. Okay, and the sine theta, where your theta is basically the latitude. You know latitudes and longitudes of the earth, right? So this is the latitude. So this is the formula. So from this formula we need to understand one thing, that at equator, okay, when we talk about equator, we know that our latitude at equator is 0. So sine 0 is 0, so Coriolis force is also 0 at equator. So basically higher the latitude, okay, higher would be the Coriolis force. So when theta is 0, Coriolis force is also 0. So what does this prove? That at poles, Coriolis force is maximum. Okay, now it also depends on the wind speed, right? So now in the wind speed, here you need to see the formula, right? Now for the wind speed, so V is directly proportional to Coriolis force. So more the wind speed, higher would be the Coriolis force. So just remember these two relations and that's enough. Okay, now let's talk about the geostrophic wind. Okay, here is a beautiful diagram I found on Google. Okay, so what really happens is, so we know, like let me create in the northern hemisphere. Let's talk about in the northern hemisphere. Okay, so this is my high pressure area and this is my low pressure area. Okay, now we know that Coriolis force in the northern hemisphere will pull or turn everything to the right. So this is my Coriolis force, okay, and my pressure gradient force is from high to low pressure. It blows from high in this direction, high to low pressure. So geostrophic winds are the winds that will exist only and only, let me write down the name of the wind. So geostrophic winds are the winds that will blow only and only when your pressure gradient force is equal to your Coriolis force. So in the northern hemisphere, due to the rotation of the earth, we know that Coriolis force turns everything to the right, and pressure gradient force, already we know that it blows from high to low. So when these two forces are equal, so there is a force, that is a wind, that is geostrophic wind, that blows parallel to the straight isobars. So this is the wind. Agar Coriolis force is less, then if pressure gradient force is more than Coriolis force, or Coriolis force is more than pressure gradient force, then this wind will not exist. So it will only exist when pressure gradient force is equal to Coriolis force. And when we say it blows parallel to the straight isobars, so consider there are isobars like this, right, around low pressure. So there will be a time when there will be a parallel. So this would be parallel, these three lines, right? So that is why it says like that. So geostrophic winds blows parallel to the straight isobars. Okay, now here is a beautiful diagram. So this is high pressure, this is low pressure, there is a Coriolis force, there is a pressure gradient force, and there is a geostrophic wind. So consider it like a string. Two people with equal force are pulling the string in both directions. So obviously it will not move. So there is something that blows here parallel to it. So these two have to be equal. So this is the geostrophic wind. Now in this topic, there is one more thing that you need to understand. So there's we know that this is the earth's surface. So there is trees, there are buildings, maybe there is some hill or something like that. Now due to these construction, the terrain near to the ground, right, so there is friction. So the wind gets friction. This is also known as a surface layer or a friction layer, which is close to the ground. So basically this friction, what does it really do? It slows the wind. Okay, and when the wind velocity goes down. What goes down? Coriolis force. Like I told you that velocity is directly proportional to Coriolis force in the formula. So if your speed has decreased, your Coriolis force will go down. So in the surface or the friction layers, right, when your Coriolis force has gone down, geostrophic wind will not exist, because now the pressure gradient force will not be equal to Coriolis force in this case, because Coriolis force has reduced. So geostrophic winds only occur above the friction layer, as below the friction layer Coriolis force is weakened, Coriolis force is less than pressure gradient force, and there will be no balance, so they do not blow. And one more thing again, so this is equator. Like I told you, the latitude also plays a very important role, which is 0 degrees. So when sine theta is sine 0 basically, right? So it is 0, so Coriolis force is 0. Now when Coriolis force is not there, in that case again geostrophic wind will not blow. So geostrophic winds do not occur between 15 degrees north to 15 degrees south, because here Coriolis force is almost or equal to 0. So here the geostrophic winds will not blow near the equator. So these two questions do come in the exam, so remember them. Next thing that you need to know is again important. So this is known as a ballot law. So what does this law really states is that geostrophic winds give rise to this law, okay? And it states that in the northern hemisphere, okay, when your back is into the wind, I'll explain you with this diagram that I have, the low pressure will be on your left side. Okay, so what it really says is here, so if this is me maybe standing, okay, and I'm looking in this direction, so when I'm looking in this direction, so this would be my left and this would be my right, okay. So when I am basically, my back is into the wind, so winds are blowing in this direction and I'm looking also in this direction, so when my back is facing the winds, low pressure would be on the left of my side and high on the right. How does this really happen? Because low pressure is anti-clockwise, so high pressure somewhat moves from high to low. So if this is high, this is low, right? So it will move in the clockwise direction like that, and low would move in the anti-clockwise, right? That this is high, this is low and all. So winds are basically in this direction, and if I'm standing and I'm facing in this direction, so my low pressure is on the left. So that is the ballot law. Gradient wind is the wind that blows parallel to the curved isobar. So this is the wind that blows parallel to the curved isobars. In this wind there are three forces that are acting. So what are these three forces? The first force is pressure gradient force, the second force is Coriolis force, and the third force is centrifugal force. What is the centrifugal force? So there are two forces, centrifugal and centripetal. So how to remember is that centripetal is center pay and centrifugal is opposite. So when you're going in a circle, right, if this is a circle and I'm riding a bike or maybe driving a car, I'm pushed in the outside direction when we're taking a steep turn, right? So that force is known as centrifugal force, that pushes you outside. So these three forces act on the gradient wind, whereas in geostrophic there were only these two forces, okay? So now due to addition of the third force, there is obviously an addition of the force on either one of the sides. So this diagram explains that, but before we go to the diagram, let me explain it to you. So let's consider this is as a high pressure, okay? So we know in the northern hemisphere, the Coriolis force, let me make it with a red color. So Coriolis force pushes everything to the right, okay? And pressure gradient, if the low pressure area is, you could say here, okay, if this is my low pressure area, so the pressure gradient force will move in this direction from high to low, pressure gradient force, okay. And now we have another force, that is centrifugal. Centrifugal also moves in the outward direction, that is your centrifugal force. So now if you see, the outside force is higher, right? Due to the centrifugal force, which is assisting the pressure gradient force, the force here is more as compared to the Coriolis force. And similarly, when I talk about in the low pressure area, we know that pressure gradient force moves from high to low. Pressure gradient force moves from high to low, and Coriolis force on the other hand will move in the right direction in the northern hemisphere. We're talking about northern hemisphere, okay? And centrifugal force will now also move in the outside direction. Centrifugal. Okay, so here the centrifugal force is assisting the Coriolis force. Here the centrifugal force is assisting the pressure gradient force. Now the forces are not equal. So that is why what happens is that there is a gradient wind that is created which blows parallel to the curve. Now it won't be straight because forces are not equal. So this is how it is explained here also. Okay. So now the winds blow like that, okay. They are parallel to the curved isobars. This is parallel to the curve. So this is the gradient wind. That's all you need to know. So this is surface wind. So what happens in surface areas? We know that in the surface area there is a lot of friction. So there are no geostrophic winds. And there is no, why there are no geostrophic winds? Because Coriolis force is less because of the lesser speed due to the friction. So what really happens is, if this is my high pressure area and this is my low pressure area and this is my Coriolis force in the right direction, and this is my, I'll make it a different color. So this is my pressure gradient force. Now my pressure gradient force is higher as compared to my Coriolis force, which is less, right? So what will happen? The gradient, the geostrophic force will not exist. But since this force is higher, it will pull the wind towards its direction. So if these were my isobars, I make it with yellow. So if these were my isobars, so it will blow across the isobars. So this is what the surface wind is basically. Due to the friction, Coriolis force is less, so there is nothing to balance the pressure gradient force. So basically surface winds are the ones that blows across the isobars. Okay, so that is the surface wind. Now let's talk about one important part where you need to understand the value. So what angle and speed does the wind change? So this also comes in the exam. So what angle and speed does the wind change? Of course, once there is more friction, it would be higher change. If the friction is less, it would be lesser change. Okay, so wind is backed by 30 degrees, then the wind speed decreases by 50% on land. Okay, so the answer to this is, on land there are trees, there are mountains, there are hills, there are cars moving, there are buildings, so there's a lot of friction. So the speed would decrease on a higher rate. So when the wind is backed by 30 degrees, the wind speed decreases by 50% on land. Okay, this is one. The other thing is the similar, when the wind is backed by 30 degrees, now this is on water, the wind, because on over the water you would know that there is less friction, right? So it decreases by only 10%. So this is on sea or water, whatever, water body. So this is also important. Now we can do a small numerical based on this. Okay, so the numerical is that, for example, in Indore, okay, surface winds are 360 degrees, so they are coming at 20 knots. Okay, 20 knots. What will be the wind? What will be the wind at maybe 3,000, 4,000, anything you could take, 3,000 feet, okay? Now surface wind is given. The question is asking about the scenario of winds above the friction layer, because friction is very low layer, right? So 3000 F, 4000 F, 5000, it is above the friction layer, and we know that the speed at 3000 feet would be higher as it is above the friction layer. So friction layer में speed कम है, तो 3000 पे the speed would be higher. So it will, what will happen? It will go in the veering direction, because friction layer पे winds back. they reduce the speed, so they go in the backward direction. But when we go above the friction layer, the winds would be in the veering direction. So if my wind was coming from 360 degrees, now my wind would be a little faster. So by 30 degrees increase, 030 degrees, so there would be a 30-degree increase. And when it is 30 degrees, how much it is? The wind will increase by 50%, like we just read over the land, right? So the answer would be 030 degrees, and the speed will increase by 50%. So my speed was 20 knots, so it will be 20 plus 20, that is 40 knots. Okay, so this kind of question can come, not very likely, but could come. So, and we know that the wind is backing at the surface, so at a higher altitude or at a higher level, the wind should be coming from the right, so it will be veering. So using the 30 and 50% rule, we can solve such kind of question. So now we are going to talk about the land and the sea breeze, which you would already know. You've studied this before also in your school days. So you know that land heats faster and land cools down faster. That is why in Rajasthan, when you see Jaisalmer and Jodhpur, so the nights are very cold and the days are very hot because of the land, right? And the water, basically the sea, it also cools and heats up, but at a slower rate as compared to land. So during night, okay, so during night the land cools down faster than sea. The wind now again blows. Now here what happens is, I'll tell you. So during the day, the land heats up faster than the water. Okay, so let's consider the day. Okay, here like in this diagram, so the land heats up faster than the day. So what happens is, there's a low pressure. So if this is my land, I'll make it red because it's getting heated, and then this is my sea, I'm making it blue. Okay, so now what happens is, because the air is hotter over the land, so lighter it becomes and it starts to rise. So here the air starts to rise. So there is a low pressure created over the land. Now what happens in the sea, it's also getting heated, but as compared to the land, there is a high pressure here. So now wind will blow in which direction? The winds will blow from high to low. So the winds blow from sea to land. So there's a relatively high pressure over sea as compared to land. The wind blows from high pressure to low pressure, and the cycle is formed, and this is known as the sea breeze. Okay, and during night what really happens is exact opposite. So during night, now what happens? Now my land is colder, okay, and sorry, I've written the, yeah, so my land is now colder, and my sea is comparatively, because the entire day it was getting heated, now it will take time to cool down, but land cools down faster. So my sea is comparatively hotter. Now because the sea is comparatively hotter, so the air above it will start to rise. Okay, so there is a comparatively, here the low pressure is created, and since the land is colder, so the air here is settled, so there is a high pressure here. Now the winds blow from high to low pressure, that is from land to sea. Earlier it was blowing from sea to land, now it will blow from land to sea. So this is known as land breeze. Okay, now the questions could be, one is this, that in which direction what blows. Now what is stronger? So sea breeze is stronger. Why? Then land breeze, as the sun is there, and hence there is a higher pressure difference due to the sun, because raat mein the sun goes away, right? So during the day the sun is there, so the land is getting heated way higher, so the difference in pressure above the land and the sea is much more. That is why the sea breeze, that is during the day the sea breeze falls. So this is why where sea breeze is stronger. Now there are another two winds that we are going to talk about. One is anabatic winds and then is catabatic winds. Okay, so what happens in, this is anabatic, okay, and this is catabatic. So during the day, the wind at the valley starts to rise because it's hotter, of course. So these particles are there, so this wind starts to rise. Okay, starts to rise. So the wind that goes up the hill are known as anabatic. So the winds that go up the hill during day, right, it's during the day, are known as anabatic winds. Okay, and in the night, because the air is now getting cooled, so it will fall down, so the air sinks right? So these are the catabatic winds. So the winds, you could just remember like this: winds that blow down the valley or down a valley at night, down the valley, that is at night, are known as catabatic winds. Now what is stronger, what do you think? So the catabatic winds, okay, winds are stronger than anabatic winds. Why? Because in anabatic winds, the winds are blowing against the gravity, whereas in catabatic the winds are blowing in the direction of gravity, so they are stronger. So here the wind topic is over, and I'll just share you the questions now. So please try to attempt these questions. You could take a screenshot and answer them. They are with numbers. You can check these questions. These are again from IC Joshi and very important for the exam point of view.
Thank you for watching my video. I hope you enjoyed. I hope you learned something today. If you have any doubts, please comment below and do not forget to subscribe.